All right.
Welcome to Talking Kotlin. We are back, and I am excited to be here with my co-host Sebastian.
Hi, Hadi. How are you?
I am good. How are you?
I'm excellent. I'm really
Y-
looking forward to today's episode, actually.
Yeah, and this is the first recording that we have done after Kotlin Conf, and I must say it was an amazing conference. Right, I came back so tired, but at the same time so pumped up with all the energy and seeing the folks from the community again, and so much excitement around the multi-platform stuff and the things that we're doing.
Oh, 100%. There was so many cool announcements, so many cool discussions to be had. It was one of those moments where I really realized how much I missed just being amongst my people, the Kotlin community, and being able to talk to them in person. It was really, really good.
Wait a minute, I thought they were my people.
I think they might be our people.
Oh, okay. I'll settle for that. And of course, the most important announcement of them all, we reintroduced the mascot.
Oh, look at that. It's so cute.
That is so beautiful.
If
It's actually quite cute. Like initially, I didn't like it, but it's cute, with the little heart and the plushiness. But yeah, anyway. And guess what? We're even more excited because today we have a special guest with us, someone that's been on the show a number of times and is coming back to talk about one of the topics that I really want to learn about this time, which is
It's Sébastien Deleuze, who's going to join us today to talk about Kotlin for WebAssembly. He's a Spring Framework core committer at VMware, but he also just does a lot of other things in the Kotlin ecosystem. So, hi, Sebastian.
Hello, both of you. How are you?
we are good.
Yeah, really,
We are
really
good.
excited for today.
So
Yes, I'm super happy to be able to talk about Kotlin WASM and all the WASM stuff. So yeah, thanks for having me here.
I think we need to get one thing out of the way first and foremost. Sebastian, you are Sebastian. Seb, you're Seb.
I'm sure that cleared it up.
That's very clear.
Works for me. Works for me.
I will.
Okay.
So I will absorb the Seb title. Very good.
There you go. Right. So if I say Sebastian, who says yes? Sebastian?
Yeah.
Seb?
Yeah.
There you go.
Look at
And
that.
I'll be Hadi.
All right.
Well, I could be Sebo. I'll be Sebo on this episode. So
It's out for me. It's out for me because everybody called me Seb, but for this hour, I will make an exception.
okay, fine. Then we'll call you Seb and Sebastian.
No.
Seb, you
Let's
can
keep
be
let's keep
Agner.
Sebastian. Let's keep Sebastian. That will be fine.
Okay. Anyway, so how you been, Sebastian?
Super fine. I'm also back from Kotlin Conf, and I was super pleased to meet everybody in person. Super nice event, super nice venue, and and it was the opportunity also to talk about Kotlin WASM and with various people, various site attendees, and usually people just come to me to talk about Spring. This year, they come to me talk about Spring, but also talk about Kotlin WASM, and that was super nice to be able to chat about the two topics with the Kotlin community.
Yeah, it's kind of like I'm not a one-hit wonder. I do more than Spring. I do WebAssembly as well now.
Yeah. So it's actually I think quite an interesting topic because if you're not entirely kind of in the loop, it might not be immediately obvious what WebAssembly even is or why there's like a necessity for WebAssembly to exist. So why don't we actually kind of motivate this whole story first of all? So Sebastian, what is WebAssembly?
Yeah, so it's true that basically WebAssembly is a kind of low-level building block where the regular developer don't want necessarily to be aware about all the details because we all develop with our programming languages, Kotlin or other languages, and it's basically a low-level bytecode format that allows to deploy your workloads by not being tied to a specific architecture. So unlike native executable or unlike Docker containers, you are not tied to a specific operating system, not tied to a specific CPU architecture. And it has been initially created to be able to run some workload efficiently in browser. So WebAssembly, there is this web part because it is originally designed to run workload inside the browser. So typically, we have used JavaScript as the bytecode of the web, and that's what Kotlin JS is doing. It's using JavaScript, which is a language, as a kind of bytecode, and that creates some issues. I guess we can talk later with the Kotlin JS team to know more about the tricks that are needed to do that, because JavaScript is not a bytecode. And so WebAssembly is a real bytecode that the web was needing. It is designed to be a suitable compilation target for low-level languages like C, C++, Rust. And currently, I think it's mostly used to, in addition to JavaScript, in combination with JavaScript, be able to run some workloads like cryptographic functions or a codecs or stuff that are typically developed in C, C++, Rust, and run that in the browser with all the security you need, etc. So it's a bit like a revival of the old plugins, but super different way, a super different security model. And it's platform agnostic and super efficient, basically.
So anyone that thinks of the web kind of thinks of everything you've said, with the exception of super efficient and low level, right? Because the web is by all means its own kind of virtual machine where you can run anything independent of the platform, etc. And this is no different. The difference here is that this is going way more low level in the with the hope of making things very performant and enabling certain type of applications that aren't currently possible with the combination of HTML and JavaScript. Is that right?
Yeah, and this is currently the main use case for WebAssembly in the browser. The perspective I take is it's also opening the web to other languages. So currently, if you don't leverage JavaScript, or if you are not a superset of JavaScript like TypeScript, you are basically not a first-class citizen. And yeah, I guess that's also why maybe Kotlin JS and other languages that transpile to JavaScript, sure, they are usable, but compared to the adoption of TypeScript, it's not the same. And if you are not JavaScript-ish, you are not web-ish. And what WebAssembly is doing, in my opinion, is that it's opening the web to other languages. So the initial move was for C, C++, Rust, because that allowed to run new kind of workloads that were not possible before without WebAssembly. But I think there is a bigger picture where it opens the web for other languages, Kotlin, Java, Swift, Python, Go, etc. And I think this is one of the key points here. And also, I guess we are going to talk about that, but it's not just about the browser. The advantages we get with WebAssembly could be used to run server-side, serverless workloads, basically. And that's where the tech community begin to be quite excited, I think.
That's a really cool use case. I think we're gonna shelve that for just a little bit, but we're definitely gonna come back, because WebAssembly beyond the browser sounds like an extra spicy topic. But I actually wanna just kind of clarify this again a little bit, because you talked about like you're kind of not webbish if you're not kind of JavaScripty, and I think it might be useful to talk a little bit kind of about maybe what the main differences are, because I mean, throughout history, a lot of languages have tried to like enter the browser, right? It's not just Kotlin. There's what is it, Mscripten for C and C++ that try to transpile those languages into, I guess, into JavaScript or into some kind of other like representation. There's stuff like Scala JS, I believe Clojure has Clojure script, all of these things. I remember that they all worked with kind of varying degrees of success. Like I remember at my university, we were using a lecture recording tool where the web player was a cross-compiled C++ application running in the browser, which was permanently spiking your CPU to 100% because the JavaScript interpreter just couldn't catch up. What kind of design decisions went kind of into WebAssembly that now, like, it's like a better compilation target? Like, is it just different than JavaScript? Is it more restricted? Do I have to really think of this as like as like a low level assembly language, really, like like the stuff that I saw in my first computer science classes, where it's just a bunch of registers or a stack, and I do a bunch of push and pop and mull and add. What does it look like?
Yeah, it's pretty low level. I think it's a trade-off. So basically, JavaScript again is a language, a garbage collected one, and has never been designed to be used as a bytecode. WebAssembly is a pretty low level. I think WebAssembly 1.0, the MVP version, is really just a pretty concise specification that deals mostly with float and integers. It can translate pretty easily to CPU instructions. So you have usually a one-to-one translation from a WebAssembly operation to a CPU instruction for the most common CPU architectures like x86 or ARM, etc. And the core WebAssembly specification was super small. And so basically, it allowed to compile the C, C++, the native languages, system languages easily to a pretty concise footprint. So just a few kilobytes. And what is interesting is that when you are using languages like C, C++, Rust, which are designed to produce pretty efficient output, you don't have to have a huge runtime. You have super small WebAssembly files, a few kilobytes, and you can have basically interaction with your with JavaScript. So it's really low level. I think WebAssembly is a pure compute engine, so by default you have access to nothing. You just do computation, and this basically pure compute engine is basically integrated into a host. The host could be typically JavaScript, could be other kind of integration like on server side. And yeah, so I think it just gets the right level of abstraction. It's low level enough to compile efficiently with to CPU architecture and execute at near native speed. It's neutral enough to be a suitable compilation target for any language. We have already tried to use, for example, the JVM bytecode to run other languages. And yeah, Kotlin is maybe the best example of that. But Kotlin is close to, I mean, it's different from Java, but it's inspired to be a suitable language for Java developers. While where you are doing Rust, C, or C++, it's just a different world. And if you try to compile C, C++ to JVM bytecodes, you you will just not get the right footprint, the right performance. So I think it has learned from the JVM bytecode. It has learned from JavaScript, and it tried to provide just the right level of abstraction. Think also about when you have to deal with numeric types and when you need to transpile some numeric types from Kotlin, for example, to numeric types in JavaScript. If you are using JavaScript as a bytecode, you are going to be in trouble because everything is float, etc. And so it just using the right level of abstraction to provide a small footprint, efficient execution, by still staying neutral in terms of CPU architecture and platform.
All right. I think probably the most interesting takeaway for me here is that it really sounds like going through JavaScript was kind of this hack that most languages did,
Yeah.
because there was no better alternative if you wanted to run it on the browser. But as you said, with anything from having floating point numbers to or having proper integer representations on the VM, to just having something that executes at near native speed, that wasn't really like possible beforehand with this kind of going through. And now with WebAssembly, we have a proper, like, designed from scratch to be a compilation target type of representation. Is that
Yeah.
right?
Yeah, we have that, and also WebAssembly is a building block. So because you may think, okay, JavaScript engine are super performant right now. JavaScript code can run pretty fast. So I think the performance benefit is not enough. But since WebAssembly is it's a pretty teeny building block, a key one. on top of that, you can build an ecosystem that is not JavaScript everywhere. Because again, if we take the example of Kotlin JS, if you are using Kotlin JS, you need to know both Kotlin and JavaScript ecosystem, both Kotlin and JavaScript build tools, repository, etc. And where I think WebAssembly is a bit different is that on top of this neutral building block, there is some ongoing higher level specification that are being built to create a WebAssembly ecosystem that will be polyglot. And so, for example, we have this WebAssembly component model specification that basically is going to define components that are written in any language compiled to WebAssembly and that import some function, export some function. They are going to be deployed to some WebAssembly repositories like NPM for JavaScript World or Maven Central for the JVM, but in a neutral way. And those WebAssembly components, tiny footprint, ID performance, will be usable in any languages that support WebAssembly, Kotlin, Python, C, C++, Rust, etc. And I think this is one of the key points where we are talking about maybe using WebAssembly for Kotlin. It's going to open, in terms of libraries, ecosystem I can use for AI, ML, or other domain where maybe we don't have yet the Kotlin multi-platform libraries, is going to add a huge number of libraries to Kotlin to be used in addition to the Kotlin multi-platform. And yeah, this polyglot ecosystem of libraries and other kind of benefits, I think this is something that is going to be super interesting because, again, you don't have to learn all the JavaScript ecosystem specificities. You are just going to build with your language plus extra power from the WebAssembly ecosystem and run that in an efficient way.
Okay, so let's go with that because you know, initially you mentioned that this is, if you're not a language that is TypeScript or JavaScript, you're a second-class citizen. So
Yeah.
now we understand that basically what WebAssembly is doing is leveling the playing field, right? It's saying it doesn't matter what language you are, you get to, you know, take advantage of WebAssembly. Okay, so now let's move on to Kotlin. So Kotlin, actually, first of all, let's start with where is Kotlin in the scope of WebAssembly?
Yeah, so I think when we talk about WebAssembly, there is three kinds of languages. The first kind of language is basically system languages, C, C++, Rust, and they already compile pretty fine to WebAssembly. They are used to implement crypto, compute libraries, other things, etc. That already works pretty well. It's allowed to produce tiny footprints, it runs fast, etc. Second kind of languages are scripting or dynamically typed languages. So here you are going to compile your script engine. So let's say, for example, the Python or the Ruby runtime to WASM, and your WASM, your script engine basically will interpret Ruby or Python file in the browser. So here it's interesting, but the footprint will be pretty big because you have 1 to 5 megabytes scripting engine that is running in your browser, etc. And in terms of speed, that's not the best. And so far, it was basically the two choice we had. And there is this WebAssembly garbage collection proposal, which is maturing for quite a few years already. So maybe people are just impatient to be able to try it. WebAssembly garbage collection is that in addition to WebAssembly 1.0 that can run these two kind of languages I talked just previously, it's going to make WebAssembly a suitable target for garbage collected languages like Kotlin, Java, C#, etc. And this is what was missing until now, to be able to compile languages like Kotlin to WASM. So this is a new WebAssembly proposal that is currently available behind the flag in the various browsers. So you can run WebAssembly garbage collection support by enabling a flag on Chrome, for example. And basically, this is what Kotlin WASM is currently using. That means that by default, you can't yet run Kotlin WASM or other languages that support WASM GC in your browser without enabling these special flags. But think about in a few months when potentially WebAssembly garbage collection will be enabled by default. I think we are coming very close to that very important step. then it open basically it make WebAssembly a suitable target for languages like Kotlin. And here I think we are entering in a new world because we can compile Kotlin code into a very small footprint WebAssembly file, and that's what I am excited about.
So, where's the technology in regards of like stability so far? So just Kotlin for WebAssembly specifically.
Yeah, so I think you have announced, a Kotlin WASM has reached the experimental status as part of Kotlin 1.8.20. I think, Kotlin WASM team is working on that for some time, but it has recently reached the experimental state, which is the first state of maturity. Before, I don't remember, alpha, beta, and stable, something like that. So it's super new. It's super early. So I won't say it's possible to write production workload with that right now. But I think the potential is big because it's leveraging the Kotlin multi-platform architecture. So basically, Kotlin has already the experience of adding new platforms, and so it really helps. In terms of footprint, I think it's already pretty good. So the latest improvement that the Kotlin WASM did allow to create a small hello world in a browser with a 3 kilobytes footprint. So if you compare to what Kotlin JS is doing, or even if we think about the potential of this teeny footprint with bigger workloads, I think it's pretty nice. In terms of performances, I think it's already better than Kotlin JS. And that's not a small thing, because think about all the optimization that has been done in the JavaScript engine and all the optimization that has been done in Kotlin JS. The clever trick is that the Kotlin WASM team is doing a reasonably optimized output, especially doing a lot of tree checking, so removing the code that is not used by doing a static analysis of your application. And then there is this binarian tool, which is created by Google. So multiple years of R&D in that tool. So binarian is a tool chain that allows to process WASM files. And there is this WASMopt utility. Basically, you feed it with an unoptimized WASM file, and it creates a smaller and much faster output. And this is what the Kotlin WASM team is using to leverage, again, multiple years of R&D from Google to optimize WASM workloads. And the end result is a pretty small and performant workload. So I think in terms of footprint performance, already pretty good, and it's only going better. In terms of maturity of the platform compared to Kotlin JS, for example, it's too early for a wide usage because a lot of things to refine still.
All right. Yeah, that makes I mean it kind of makes sense. So just to kind of recap to see whether I understood this one correctly. So we're working with some pretty cutting edge technology here. Um the Kotlin for WebAssembly target is using the WebAssembly garbage collection proposal, which I mean that makes sense because Kotlin is a garbage collected language. We don't really have, I don't think anywhere we have a memory model that is now different from garbage collection. And I know that so Kotlin native used to have this different type of memory model, but sometime in the range of Kotlin 1.7, that got moved into actually providing a runtime that also uses garbage collection. So it kind of makes sense that WebAssembly would also use garbage collection, so that things behave the same. That part checks out to me. Um, it also makes sense that all of this is still experimental because it's quite new. But especially since it's using a technology that is still behind a flag. But I'm also hearing from this that I can already take a WebAssembly application written using Kotlin, and I can run that in just like the browser that I have. I might need to turn on a toggle, but I can already run it in the application, and then I assume a couple of months down the line, when this proposal has moved further, hopefully the applications will just run kind of out of the box in the standard configuration. Is that reasonable to say?
Yeah, and I think there is two main things that need to happen to make that easily usable by everybody. The first one is indeed to get the WASM GC proposal just supported by the various browsers out of the box. And I think that will happen within a few months. The second point is for the Kotlin multi-platform ecosystem, Kotlin multi-platform libraries, to add WASM support like there is native JS JVM support. And it's usually not a huge work. It's usually adding just the WASM specific code that will basically combine with the common multi-platform code, allow to run your application on WASM. We have already experimented with the Kotlin WASM team on doing that on a few libraries. I think on your side, on Compose, there is already some experimental work that allow to basically compile a Compose for web application to WASM. So yeah, still some work to make it first class, and there is a lot of experimental version of the libraries. But technically, you just need to add the small specific WASM bits, and you can just leverage the Kotlin multi-platform libraries that you already use for other use cases. So Kotlin serialization and others.
I mean, that's a super casual way of kind of dropping at the side and being there like, oh yeah, there's already a version of Compose multi-platform that runs in the browser. I think we need to talk about that just a little bit more. Um, I also I might be slightly personally invested in this because I did show a demo of this at KotlinConf.
I remember a huge crowd around your computer when you were showing the Compose for Web demo with WASM. It was quite amazing. I think it got quite a lot of traction at KotlinConf.
Yeah, and I hope that we'll have something that shows off Compose for WebAssembly on the Kotlin YouTube channel soon as well. So do keep an eye out for that. Just a small look at it because that would be nice. But yeah, so for people who aren't quite in the loop, I think it's important to note that at JetBrains we run this project called Compose Multi-Platform, which takes which essentially takes Jetpack Compose, so the framework that you use for building declarative UIs for Android, and brings it to a bunch of other platforms. And during we already have Compose for desktop, which is stable, which we've actually already talked about on this show with Victor Kropp. But at KotlinConf 2023, we also announced support for iOS and alpha, and a first experimental version that runs on top of Kotlin for on top of Kotlin for WebAssembly. And what's particularly exciting about this is, at least from my perspective, I had not expected it to perform this well. When I first opened the demo that we had built, just as an example, it ran very smoothly. It behaved, because it's just another Kotlin target and not some kind of weird transpilation. It behaved exactly the same way as it did uh, on desktop or on one of the mobile devices. So I was really quite impressed, and it kind of showed me that that there's definitely just value there when you can take essentially a full Kotlin application, like user interface and all, and just bring it also to the web browser with a decent performance.
But on that note, I want to ask, me as a Kotlin developer today, ignoring the fact of that this is still experimental, right? And you say that this is not for production code. I guess it depends where you put your quality bar, right? So, like literally, no one is preventing you from putting experimental code into production, apart from your customers then paying you. But what can I actually do today with Kotlin for WebAssembly, even if it's just playing around? Like, what type of applications can I create? And let's forget Compose multi-platform for a second.
Oh.
No, we'll come
so
back to that, but I just want to forget that for a second.
All right.
So you can use it to create web applications. So I mean, you can use it to create what you were doing with Kotlin JS, for example. So you can create front-end code. You can create so compose application. You can create. We have experimented by creating new front-end code using some specific libraries. You can leverage it to share business logic between front-end and back-end. So imagine you have your Kotlin multi-platform business logic that is using potentially some libraries like conform with a K. You can share easily this logic between front-end and back-end, etc. But you can also, and that's where I'm currently experimenting, you can create some server-side workload. So that's why I have created this WASM project that is currently experimenting around that. So it's nice to be able to create application with Kotlin WASM that targets the browser. It's nice to potentially be able to leverage Node.js API or whatever to create application, but you can also create new kind of workloads that just target basically server-side workloads. And that's where I think there is a huge potential for Kotlin. It's not just to be in the front end, it's also to be able to share code between backend and front end. It's also to create server-side application that will start super fast, are independent of the architecture. And that's where I'm personally pretty excited, mainly because of my server-side developer background, but that's really where I want to push a bit.
But let's go back to the front end applications, right? You
Okay.
say I can create web applications right now.
Mm-hmm.
And one thing that you mentioned previously is that, you kept saying how with WebAssembly, you no longer need to know the Java ecosystem, the JavaScript ecosystem, right? How do I actually work with that? Like, don't I need to know the how to work with the DOM? Can I work with Kotlin directly with the DOM using WebAssembly, or do I need to go through JavaScript? How do the APIs work?
I think this is a
Yeah.
really, really good question because I think classically in the WebAssembly discourse, one of the key points has always been it's kinda icky to work with like the browser itself. Like it's a really nice model for doing a bunch of number crunching or calculations, but then reaching out conveniently into the browser world, that part has always, as at least from what I've heard, has always given people a little bit of trouble.
Yeah, there is mainly two big strategies. So to render a website with Kotlin WASM, you basically have two big options. The first one is to use the DOM. So you're not directly using JavaScript. Currently you have to go through JavaScript, but that's a bit hidden. So in Kotlin WASM, you will have a DOM API like you have currently in Kotlin JS, and you are going to create your elements, etc., and manipulate the DOM. And I'm personally a bit excited about that with WASM, but we can talk maybe about that a bit later. So it's just the regular way to you just continue to use the DOM to create a GUI with Kotlin WASM. The other option is basically you create a canvas that is baked by a shared array buffer, and then you will just directly render your GUI. And I think that's what Compose for Web is doing in a pixel perfect manner without using the DOM, which can be slow, where you can't really control precisely how that will be rendered. So here the trade-off is a bit different. You are going to provide your own rendering engine. So typically, various software are currently compiling the Skia 2D rendering engine to WASM and using that to render pixel perfect UI on the browser. And yeah, so you maybe lose a bit of accessibility. You need to provide maybe a bigger rendering engine. But once you do that, you can perform pixel perfect rendering of your application. And I think that's a bit what Compose for Web is doing. But Seb, you know maybe more than me about that.
I mean, I can definitely. You're exactly right. So Compose for WebAssembly is doing exactly that. So it's essentially just rendering on top of a canvas, which is why probably for the time being the main use case isn't to take your run of the mill, like, I don't know, blog website and turn it into a Compose for WebAssembly application. Because if you're just there to show a bunch of text and maybe a couple of images, it would be quite crazy to ship your own custom rendering engine and all of these things. the real benefit is exactly if you have an application already built, for example, or if you're building an application that's maybe quite complex or that has a bunch of interactions for Android or for the desktop, or in the shared case, and then spending very little effort to kind of bringing that to the browser. Um, I'm pretty sure that the team is quite committed on providing accessibility integrations also for Compose multi-platform. So hopefully that experience doesn't we don't have any degradation in comparison to other web applications. What is probably a bit harder might be search engine optimization, right? Which is again why if your main goal is to get your website discovered and like ranked at the in the top search results, then most likely just a basic website is going to always do a better job than that. But if you have really complex interactions, right? If you're the next Figma or like, I don't know, the next Google Docs or whatever, those are all programs that actually already render on top of a canvas, just like Compose does. Then it might be a good kind of use
For the
case.
Yeah.
record, ChatGPT has said that SEO is dead, so we can just ignore that now.
Wow, did you ask it?
Well, no,
And it just
someone on Twitter said, "Here's how 10 things are going to change with ChatGPT," and one of the tweets said that. So I'm taking that as gospel. Yeah, yeah,
all right, cool. Yeah, that's always believe growth hacker Twitter
exactly.
threads. You had heard it here
Yes.
first. I just to round things out, because you said we can access the DOM. Um, is it just the DOM, or like what about the rest of the browser APIs,
Yeah.
right? Because the browser, you can do like a lot of things. Like nowadays, anything from just making network requests to accessing, I don't know, the gyroscope and sensor data on mobile devices, like all of these things. Are those also exposed
Yeah.
to Kotlin for web?
Yeah, everything is exposed because everything is generated from the same web IDL. So you can basically access to any feature accessible from JavaScript. You will be able to access it with Kotlin WASM. Currently, technically, it goes through a layer of JavaScript, but that's totally hidden. But it's interesting to think a bit about the future. Currently, you go through JavaScript and then you are basically reaching some feature implemented natively by the browser. It's not impossible that with the future evolution of WebAssembly, you will be able to totally skip the JavaScript layer and just directly target the internal implementation of the browser, allowing more performance, etc. I just want to talk back about this DOM versus canvas thing, because that's a super important topic. So I think there is really two different use cases: Compose for web, canvas rendering, be able to do pixel perfect rendering between Android, mobile application, desktop, web. Super important, perfect use case for back offices, application where you don't need to care about the footprint. And even for Spring, I could imagine that people could build some back offices using Compose for web and doing very dynamic GUI, etc. But yeah, I have the feeling that for e-commerce, for websites, when the footprint is important, it would be great if we could have some small footprint DOM-based alternative that would be basically the React of Kotlin or something like that. So maybe it could be Compose for HTML, or maybe that will be something else. But I think we need both. We need Compose for web and canvas rendering for back offices and application. And it would be great to leverage this super tiny footprint with Kotlin WASM, 3K for Hello World. So think about if we had a framework based on Compose architecture that could take, I'm not sure, 20 kilobytes and allow people to create website, accessible website, etc. with that. And yeah, so drawback would be you can't leverage your mobile or desktop Compose for web components. Advantages is that you have a super tiny footprint and you are just leveraging the web APIs directly. So I think this is two complementary approaches. But I also understand why Google and JetBrains maybe focus a bit more on Compose for web, because it allows so much reuse, and maybe that's the future. Maybe we will continue to need both variants. I'm not sure.
Okay. But so just to quickly summarize this point on using kind of the browser APIs again, because I think that's kind of important. So it uses WebIDL, which I guess is the interface definition language, and that means that all the stuff that you have accessible in Kotlin JS or just in the browser, whether that's some kind of request making APIs or sensor access, that's all available, and it's actually available kind of under the same, like in the same structure. It's transparent to you. It's as if you were just in the JavaScript world, and while there happens something in the background, some kind of translation layer, uh, that might be temporary, that might be switched out at some point. The main point is just that you don't really have to care about it, and that's really cool. Um, so I I think we still have just a little bit of time, so I'd like to move on, and I think this is also one of the parts that you were quite excited about, and that's kind of seeing the use cases of WebAssembly beyond the browser, which is quite fun because it seems to mirror the story of JavaScript a little bit, right? Like JavaScript started in the browser, and then someone said, "Hey, what if we run JavaScript outside of the browser?" And then Node.js was born. And it seems that there's kind of a similar idea going on with WebAssembly, where they're saying, hey, we have this platform independent, like low level specification of what is essentially kind of like a virtual machine, that we can run wherever. uh, let's try and rip that out of the browser as well, and run it in other places. So do you want to talk a little bit about that?
Sure. Yeah, I think you can draw some parallel compared to JavaScript, Node.js, and also with the JVM. So yeah, so basically the idea is you have WebAssembly, this platform neutral format, secure, fast, can be a compilation target for every language. You can instantiate workloads in a few microseconds, so super efficient for potentially serverless workloads. So what if we were using that to deploy server-side workloads and run that on the server? So in parallel of the browsers that ship WebAssembly engines, you have some pure WebAssembly engines like WASM Time, WASM Edge, that are just shipping a WebAssembly engine, and basically they can run this and also interact with the system using a new specification which is called WASI. So WASI provide access to your WASM workloads, to the file system, to random number generation, to do stuff on your machine, basically, like you do with Java and other languages. So
And what does that stand for? What does WASI stand for?
it's a WebAssembly system interface,
Okay.
and it's not a monolithic thing. So, and that's maybe where the WebAssembly ecosystem is a little bit hard to follow. So currently, you have what we call WASI Preview 1, which is a basic version, a low-level version of WASI. You can deal with the file system, and basically that's it. And there is a next generation of WASI, which is WASI Preview 2 and what will be WASI 1.0, which is breaking this monolithic thing into various subsets, which are WASI file system, but also WASI sockets and WASI HTTP and other stuff. And the interesting thing here is that you are going to create web application and what AI or ML workloads and compile that to WASM using those WASI interfaces. And you will be able to deploy that in whatever cloud platform support WebAssembly plus WASM, etc. WebAssembly plus WASI, etc. So it's a kind of new kind of JVM. It's a kind of alternative to Node.js. It's also an alternative to containers. So it's interesting to notice that Docker has added support for WASM and WASI recently. So I think with WASM and WASI, we are removing one or two layers of abstractions. Instead of shipping your container with the JVM inside a container, that will be architecture specific. And typically it will be 100 megabytes, something like that. You will be able to ship a 1 megabytes WASM plus WASI file. You won't be architecture or CPU specific. You will be able to deploy these workloads and in a much more efficient manner, because you don't have the JVM layer. You are you are deploying a WASM files instead of a container. And that's maybe where server-side developers can begin to imagine what that would be in terms of ecosystem. If you can deploy directly your WASM file instead of a container, you deploy, more efficient workloads, no architecture-specific stuff. You can run it cheaper, perfect fit for serverless, etc.
Yeah, I was quite impressed for this when I was downloading Docker the other day. I remember they actually had a huge banner on their website just saying Docker plus WebAssembly. And yeah, so they're currently really experimenting with this, and it does seem like just a really cool way of saying, hey, we now have, like, we've agreed on the universal virtual machine. So obviously, our hypervisor that's responsible for spinning up virtual machines and kind of managing them, it's just gonna natively support like this WebAssembly virtual machine out of the box. So that you don't have to at every point instantiate another layer of Linux and another kernel in between, and then kind of run your workload on top of that. So that's actually quite exciting. And I yeah.
And you don't have to. You also remove a lot of security issues because you don't need to ship an operating system with each workloads like you do with a container. So I mean, it's also much more secure because of the WebAssembly security model, and because you don't have to ship a streamlined version of Ubuntu or whatever operating system with your workload. So that's also a huge benefit.
And I think it goes to show again just kind of what kind of portability that WebAssembly enables. So one of the other topics that I've seen, for example, is that there's more software systems that allow people to write plugins using WebAssembly, for example, as well, which I think is quite cool because, yeah, it's shaping up to be this universal runtime where beforehand you might have allowed your users to provide a short custom JavaScript snippet. Now they can just tell you, well, just upload a WebAssembly binary that uses part of our interfaces, and it runs faster, and most importantly, you get to choose the language that you write things in. But of course, one of the points that you mentioned here is this WebAssembly system interface, which again, at least in my mind, this kind of mirrors the story of JavaScript and Node.js, where they were like, well, now that we've got JavaScript running outside of the browser, it would be really nice to actually be able to, like, work with the underlying system to be able to start sub processes, or to go ahead and interoperate with the file system in a non-blocking manner. So my question then is, how do I leverage the WebAssembly system interface from Kotlin?
Yeah, so from Kotlin, there is not yet dedicated support. Like Kotlin WASM is for now designed for targeting the browser. But I have been collaborating with the Kotlin WASM team to basically experiment on WASI support for Kotlin WASM in order to create server-side application. So this is what I do in the KoWASM project. So kowasm.org. You can check the GitHub repository. There is some documentation, and basically, the Kotlin WASM just provide some teeny APIs, teeny low-level APIs that I'm currently leveraging in KoWASM to provide APIs to manipulate the file system, to do web application, and the middle long-term goal, at least that's my hope, is that later Kotlin WASM will directly support both browsers and server-side application with WASI. And basically, this is two variants of the same WASM platform where you choose in your Gradle configuration if you are doing a Kotlin WASM front-end application or a Kotlin WASM server side. And yeah, but there is some low. I mean, WASI is currently under heavy work. A lot of changes. They are currently leveraging WASI on top of WASI WASM component models. So yeah, WASM itself is super stable, but there is a lot of discussion, either friction and technical evolution on this WASI layer and the WASM component model. So everything is still very much in flux. And I think it will take at least a few months for that to stabilize. But for now, it's moving forward on the experimental side via WASM. And that also allows the Kotlin WASM team to provide feedback to the WebAssembly working group to make sure that WebAssembly is a suitable target for Kotlin. So that's great to be able to be here super early.
That's really cool. Now, I think we might be pretty much almost out of time for our discussion for today. But I do have just one more kind of more personal question. What's kind of like the coolest thing you've done so far with Kotlin for WebAssembly in all your experimentations? Could be anything, but is there anything that where you felt like, oh, this is awesome, or this is something that I really enjoy?
I think it just being able to just stop to have text silos between front end, back end, etc. Like I write my code with Kotlin WASM, and I'm able to share it between front end, back end, etc. without having to deal with all the technical platforms you have with Kotlin Native, for example. With Kotlin Native, if you want to target all the technical architecture, you have to declare the 25 variant of your application, sometimes adding the specific code for the WatchOS, the WatchOS specific variant, etc. That's just a nightmare. So I think what I'm the most excited about is that with Kotlin WASM, that's a very good fit with Kotlin multi-platform that allow to not just at the developer experience level, but also in terms of deployment. Basically, it's unify how you deploy application, and you can stop wondering about specific operating system stuff, etc. So I did some example like that in the CoWASM project, and I'm pretty excited about that.
All right, cool. And that's, I think, something that people can then hopefully also explore by themselves. We'll make sure that CoWASM and all the other fancy words like binary and so on, we'll all have those
Yeah,
linked,
and
of
that
course,
takes me to the
in
point
the show
of
notes.
one thing you said at the very beginning, which is uh, WASM is a low-level thing that the user really doesn't need to know, right? And then I imagine some of our audience listening to this is like, wait, you said I just need to know Kotlin, right? So uh, if I'm a Kotlin user right now, where do I go to start experimenting with these things? What is the first step? Do I need to read up on WASM, or could I just download some version of Kotlin that targets WASM and write my Kotlin code and then somehow deploy it to the browser?
Yeah, you can do that, and there is not that much from WASM you need to know. Just you will declare the WASM platform instead of the JS one, and most of the rest will happen low level. I think a bit later, when we will be able to leverage some WASM components written in other languages, you maybe will have to declare a specific repository to leverage a component written in Rust or in C++ or whatever. But that will be most of it. I think most of the work is done by the compiler engineers in the Kotlin team, and the end user will just be able to deploy more efficient workloads without wondering about specific operating system, a specific CPU architecture, deploy it in the browser on server side, and it run everywhere in a cheap way, and that's it. So in the end, it should be super simple for the user. But yeah, there is quite a journey on technical level for the Kotlin WASM compiler engineer and the community. So yeah.
So you heard that from this podcast. If you want to join the team that is developing this stuff, get down and dirty with WASM. Otherwise, just use your favorite Kotlin application and even maybe try Compose multi-platform WebAssembly, which is an experimental thing targeting another experimental thing. So knock yourself out with experiments on that one. And yeah, so with that, we are out of time. Sébastien, it was great having you. Seb, it was good having you too. And
My pleasure.
thank you once again for coming on the show.
Bye.
All right. Yeah, thank you so much. And we hope that, of course, everyone else will tune in for our next episode.
Which will
Yeah.
be?
Who knows? You're gonna have to tune in to
Exactly.
find out. You are gonna have to tune in to find out when it's gonna come out.
We don't even know when we're going to record it. So there is that.
That's right. We're winging it.
We're winging it. Yeah.
That's
We're
the secret.
web assembling it. God, never mind. Yes. Bye, Seb.
Yeah. Take care. Bye bye.